All right, in this video, we're going to talk about section 10.3, the first half. And we've been going through geometry, and now we are introducing space figures. So what we're looking at in this section is figures that are existing in the third dimension. So a space figure is a figure in the third dimension. And we've looked at one type of space figure previously, and that was a plane. So a plane floating in space here could go on infinitely in every direction. But we can, visualize planes in our own room. You might remember the tabletop, the ceiling, the wall, the floor. All of those are examples of planes. Okay, so we're going to add some more terminology as we start looking at 3D figures. First thing, intersecting. It's possible for two planes not to intersect. That would mean that they're parallel. I'm going to do this plane in green. And then let's say you can't see that part, so I'll use dashed lines. And there we go, pops out. Just kind of draw a line where those two looks like it's a right angle, but it doesn't have to be, of course. We actually have a name for that angle. That is called a dihedral angle. So that is an angle formed that's an M, though it doesn't look like an M, formed by two planes. Awesome. Okay, so it's also possible to look at a plane and a line existing in space. Have a plane, and you could have a line, and maybe the space, and let's say it intersects the plane right here and goes that way. That's possible too. We can have a line. The line could actually lie in the plane, meaning it's on the plane itself. So it could be free from the plane. It could be on the plane. It could intersect the plane in exactly a 90-degree angle. All the geometry we talked about extends to 3D. Okay, so let's talk about shapes in 3D. We have some names. The first is a polyhedra. All right. So a polyhedra is the plural drawn. So let me define that. So a polyhedron is a simple closed surface made up of polygonal regions. Think golf ball. You know how you look at a golf ball and it's not perfectly round, but it's shapes that make up the golf ball? That would qualify as a polyhedron. Okay. And there are multiple types of polyhedron. It doesn't have to be not smooth. Smooth, but we'll talk more about that later. Before we do that, I want to give us one more definition. A polyhedron is convex. So we've seen this phrase before when we talked about polygons. Is convex if the line segment connecting any 2 points is contained inside. Wow, that's not how you spell contained. It's contained. Let me go ahead and, oops, we'll draw a couple. So let's see, how about kind of like a tent, a tent shape. That is a convex polyhedron. Because if I were to like grab a couple points on the surface, like let's grab one on the flap of that tent on this side, and then let's grab one on the bottom here. It's with a line segment. That line segment is going to be inside of the polyhedron. Okay. Sorry, I was looking to see if we have another example that maybe isn't. And yeah, let me give you one that isn't convex. So how about this shape? We'll do kind of a funky, like almost Star Trek shape. If you ever have any familiarity with Star Trek here. It's terribly drawn. There we go. All right. And then let's say it goes like this. And then it goes down there. Imagine. Oops. I drew that a little bit off. There we go. Go up there to the side. And then the sides connect. And then those connect. All right. It's possible to draw a line segment outside, would be outside of the polyhedron. So this would be an example of it not convex. Okay, now if anybody has any familiarity with that those shapes are what we would call regular polyhedra. And a regular polyhedra is when the polygons that make up the faces, the polygons that make up faces of, oops, the polyhedra are congruent. It doesn't need a comma. Are congruent or equal, the same, right? That's what congruent means. So a simple example of this that's not too difficult to draw would be a cube. A cube would be made up of squares. So here, we'll kind of draw the top and then the sides, pretending that they're all the same and not a little bit rectangular there. That would be an example of a regular polyhedra. Okay. The book has some really pretty pictures that you could go look at. Another one that's not too bad to draw is one that's made up of triangles, equilateral triangles. Okay, so I'm going to do my best. So pretending that's an equilateral triangle. And then another equilateral triangle on this side here. And then another one in the back. And then a triangle in the front. So if it was made up of equilateral triangles. And they call these kind of shapes, and we're going to get into this, pyramids. Made of equilateral triangles. But if you look at their examples on page 662, they have some really pretty pictures in figure 10.44. Better than what I can draw. Okay, it's possible to create a shape made up of semi-regular polyhedra, or let's say semi-regular polyhedron, use the singular to discuss it. Polyhedron is one that has two or more regular polygons as its faces. So grab your book, maybe pause the video and look at page, wow. You can see examples of this. I just kind of ran that together. On page 663, figure 10.47. There's some nice semi-regular polyhedra. The combination used for a soccer ball made up of hexagons and pentagons, that might be something you can kind of visualize in your head. That would be a semi-regular polyhedra. And they actually have an example of that in figure A. So that would be like a soccer ball. Ooh, that's not high school soccer. Wow. Soccer ball. And it is made up of pentagons and hexagons. All right. Now I mentioned a pyramid, and a pyramid is specific connotation in geometry. So let's talk about pyramids, and we're also going to talk about prisms at the same time. Pyramids and prisms, they kind of go hand in hand. Wow. So a pyramid is when you have a base polygon So you have a base polygon that, or whose faces go to a single point. So like the pyramids that we see in Egypt, where they may have a square base. I'm going to have to do a better job than what I just did there. I'm sorry. I'm going to have to dash the back lines. And then the front lines will be solid. Okay, and then they have a single point up here that they all connect to. All the faces connect to. Dashed line there. Okay, there you go. That is a pyramid where they've got that single point at the top. All right. And it's possible, or I should say it's typical to describe the pyramid based on the polygon that makes up the base. So this base here, right, this base right down here, that would be called a square pyramid. Possible that the point typically call a slanted pyramid oblique. So let me just draw an example of that. The best of my ability. So I'm going to try another square base here. And here I'm going to give myself a little more space. Okay, so, and let's say the point is over here this time. So it's kind of lopsided. they would call this an oblique square pyramid. So still has a square base. The tilt makes it oblique. And the oblique has to do with the angle formed on the slanted side out over here. The fact that it's greater than 90 degrees. Okay. Now, the difference between a pyramid and a prism uses a polygon base, but it doesn't come to a point. The sides are all parallel to each other. So a prism has a polygon base, but the faces are parallel to each other. So let me give an example of that. I'll do my best. Let me dash that. Okay. So there's a triangle. If I were to draw all the tops straight, what'll form on the top is another triangle. If I drew this correctly. That is exactly like the triangle at the base. So this is what we call a triangular prism. I don't know why I said triangular and wrote triangle, but triangular prism. And of course, what would be called a rectangular prism. A little bit easier to draw, I think. Oops, should be dashed. Top ends up being a mirror image of the base. Okay, so that's a rectangular prism. Now, you don't have to draw these perfectly, of course. That's not an easy task. We just do the best we can. And hopefully be able to identify the ones that, that we see. Okay, so let's go ahead and I want to look at the try it on page 665. And we're going to step through that together. So I'd appreciate if you take a second. Oops, sorry, 2.3.2. Turn to it really quick because I'm not going to write down everything. I might draw the picture to the best of my ability, but we'll go through and answer the questions. Sorry, this is on page 665. All right, so this one is a right prism. Oh, the right is referring to the fact that the angles formed with the sides are right angles, these angles right there, or even on the triangle I drew. This would be considered a right prism. So if it happens to slant, kind of like a squished figure, that would be oblique, just like it would have been for a pyramid, oblique, if it's a little slanted. Okay. So they have a pentagon. I'm going to attempt to draw it. So I'll start with the top. Best of my ability here. Wow, my ability is just not that good. So it's not supposed to be so. There we go. And okay. So it's supposed to mirror what I have up top. Oops, let me erase a little. Okay. There we go. Wow. And they have all of this labeled, right? They have a bunch of points labeled for all of these. I'm not going to draw that because I think that would really bog down my very badly drawn picture. Again, look at the book, refer to it there, so that way you can see what it's supposed to look like when it's not drawn so badly. Okay, so those are all solid lines. All right, that looks a little bit better now. All right, so number one, they ask, what is the measure of the dihedral angle between the face ABGF? Okay, so I definitely have to look at the picture here. So ABGF, I'm going to actually label it on mine, and that'll help us identify the face. So ABGF. So it's this left side right here, that face. And they want to compare it to BCHG, which is the front face, this face right here. So they want to know the angle between those two. So basically, I'm trying to find the angle right here, formed by FGH on the top, or in other words, the angle for a pentagon. I'm just going to call it FGH, but it is the dihedral angle. And that angle, let's see, for a pentagon, if I recall, let me think, we would do, I'm going to refresh my memory on a pentagon. It's been a bit. So there's a pentagon made up of a triangle and a quadrilateral. So that's 180 plus 360. And you could go back, look up, of course, this angle. So that's a total of 540, which I'm going to divide by 5. 108. So there we go. All of the angles are 108. I don't know why I'm doing this in black. That's so weird. Oh, well, because I wrote it in black on the picture. FGH. Here, I'm going to write it in green, is 108. Okay, number 2. What is the measure of the dihedral angle between GH, there we go, GHI, JF. Oh, okay. So I'm just trying to follow along. GHI, I is, by the way, this point right over here, and J is right here. So basically they're saying, because it's kind of bogging everything down. To the face right side this time. Technically doesn't matter. Already told us this is a right prism. So we already know the angle that's formed between the top and the bottom and the faces are right angles. So the answer would be a right angle, or you could say 90 degrees. Since we can answer the first one in degrees. Okay, so now name 2 faces that are in parallel planes. So that means that are parallel to each other. And the only 2 that would work would actually be the top and the bottom in this example. Otherwise, they're all going to intersect. So that would be the top face would be, they labeled this a second ago. I just realized I did this in green. That's driving me up the wall. It needs to be a number 3. GHIJF. So that's the top one. And then the bottom one is ABCDE. So basically the 2 pentagons would make up 2 parallel faces. And we'll continue with space figures in the second half of this section.